Hi students, once again I welcome you all to my channel Abrar classes. Today we will be seeing problems on the topic change of area in magnetic field, which lies in the electromagnetic induction chapter. Okay, I will teach you how to solve problems in just 45 seconds. This is the first problem. What it is saying, figure shows planar loops of different shapes moving out of or into a region of magnetic field which is directed normal to the plane of the loops away from the reader. Determine the direction of induced current. You have to find the direction of induced current in each loop using what? Lenz's law. Okay. Now here what is happening? Okay, area is increasing. You know, in the previous videos you would have seen, if area increases, what happens to the flux? Flux also increases. If flux increases, what happens? Here I have tried to explain you. Area inside the region of magnetic field increases, flux increases. What happens? Flux increases, but coil will try to decrease flux by producing field which is in opposite direction. Okay, which is in opposite direction. Now this we know that it is what? This is okay, inside, and this is outside. Okay, this is what? North pole, north pole, and this is what? South pole. Okay, south pole. We know in south pole how the direction of current will be in the clockwise direction, in the clockwise direction. Okay, in case of north pole, it will be in anti-clockwise direction. It will be in anti-clockwise direction. Okay, it will be in anti-clockwise direction. Induced current. Okay, now here area is increasing. If area increases, what happens? If area increases, flux increases, therefore it will produce a field which is in opposite direction. This is what? B induced. This is B induced. Now in case of north pole, we know that the direction of induced current will be in the anti-clockwise direction, right? Okay, anti-clockwise direction. Now here anti-clockwise direction. Now, in the second case, what is happening? Area is getting reduced. If area is getting reduced, what happens to flux? Decreases. We'll read the second point. Area inside the region of magnetic field decreases, flux decreases, no doubt. Coil will try to increase flux by producing field which is in same direction. Same direction means here it will produce a magnetic field of same direction. Now here we know that it is what? South pole. Here the direction of current will be in clockwise direction. This will be in clockwise direction. Hope you understood this one. This is clockwise. First one is anti-clockwise. Second was what? Clockwise direction. Now see the third one. In third one, what is happening? Again, area is getting decreased because it is coming away. Okay, this loop is coming away. Since this loop is coming away, area is getting decreased, flux decreases. Therefore, it will produce B induced will be of same direction. Okay, south pole. Therefore, it will be again clockwise direction. It will be what? Clockwise direction. Induced current will be what? Clockwise direction. I induce will be clockwise direction. Now here, what is happening? Area is increasing. Since area is increasing, it will produce magnetic field which is in opposite direction. Therefore, here the direction of current will be in anti-clockwise direction. Why? Because area is what? Area is increasing here, right? Area is increasing. See, whenever area is increasing, it is in anti-clockwise direction. It's in the anti-clockwise direction. Okay? Area increasing, anti-clockwise direction. Area decreasing, clockwise direction, because it will produce magnetic field of same direction. Here it is in opposite direction. Hope you understood this. This is the very first problem. We'll see the second problem. Again, same problem, same type of problem. Use Lenz's law to determine direction of induced current in the situation described by figure. This is the figure 6.16. Here again, what is happening? What is happening here? Area is what? Area is increasing here. Therefore, flux also increases. Flux also increases. So it will produce magnetic field which is of opposite direction. okay, which is of opposite direction. Therefore here induced current will be in anti-clockwise direction, will be in the anti-clockwise direction. This is induced EMF, I mean induced current will be in the anti-clockwise direction because area is increasing. Now here what is happening? It is shrinking. Shrinking means what? Shrinking means what? Area is getting decreased. Area is getting decreased. Flux also what? Decreases. Flux also decreases. Therefore, it will produce a magnetic field of same direction. This is B induced. B induced. Therefore, okay, what happens? If it is B induced, again it will be in the anti-clockwise direction only because field is same. Okay, we know that when it is dot is this anti-clockwise direction. This is also anti-clockwise direction. Anti-clockwise direction, that is I induced. Hope you have understood. Okay, we'll go to the next problem. What it is saying, a conducting loop of radius r is present in uniform magnetic field B perpendicular to the plane of ring. Okay, if radius r varies as a function of time, r is equal to r naught plus t square. What is happening? Here we know that what is flux is equal to B into A. Okay, what is d phi by dt is nothing but what? This is B. What is area of a circle? Pi r square. Okay, okay, d phi by dt will be equal to what? D by dt of B pi r square, right? Which is constant. You can take this B and pi constant. Okay, d by dt of r square. Now here the same thing is what? B into pi into, okay, what is differentiation of r square? 2r, that is dr by dt. Okay, therefore I can write this as 2 pi r b into dr by dt. The rate at which this radius changes, either it expands or shrinks. D phi by dt is equal to, right? Now this is the EMF induced. EMF induced is given by what? E is equal to d phi by dt. That is given by E is equal to what? E is equal to 2 pi r b dr by dt. Okay, this is the formula. Now, what is r given? Okay, r is given as what? R is given as r naught plus t square. Differentiate this. Okay, if I differentiate this, what I am going to get? Dr by dt is equal to differentiation of a constant is 0. What is differentiation of t square? Differentiation of t square is what? 2t. 2t. Right? Now substitute this one in this equation 1. Okay, this is the equation we have derived. Okay, E is equal to 2 into pi into r is how much? R naught plus t square. Right? Okay, B will be as it is. Dr by dt is what? 2 into t. That is nothing but is equal to 2 into 2 is 4 pi b t into r naught plus t square. Okay, this we got. Now whether it is clockwise or anti-clockwise, what is happening? See dr by dt. What is happening? Dr by dt is what? Dr by dt is 2t. Is it positive or negative? It is positive. It is positive means area is what? Area is, what is happening? Area is increasing. Area is increasing. If area is increasing, what happens? Flux increases. If flux increases, what happens? It will produce a what? Field of opposite direction. Okay, B induced. This will be what? B induced. This will be B induced. Therefore, here you will get what? A induced EMF which is in opposite direction. Opposite direction means anti-clockwise direction. This is in anti-clockwise direction. B induced, okay, is of opposite of B. Therefore, E induced will be in the anti-clockwise direction. This is right answer. Be careful. This is this. Okay, these are not the correct answer. The correct answer is what? 4 pi bt, 4 pi bt into r naught plus t square in the anti-clockwise direction. In the anti-clockwise, this is the right answer. Hope you understood this. Okay, very easy sum based on only one formula, but you have to be careful whether dr by dt is positive or negative. Okay, if it was negative, it is in the other direction. Hope you understood. We'll go to the next problem. What it is saying? Again the same problem. Okay, E is equal to, what is the equation we got? 2 pi r b dr by dt. Okay, hope you understood this equation 1. 2 pi r b dr by dt. We just remember, just substitute how much is r here. Okay, how much is r? R is equal to, what is given? R naught plus of t. Okay, what is dr by dt? Dr by dt is, what is differentiation of a constant? That is 0. Differentiation of t with respect to t is 1. Again it is positive. Positive means what? Area is increasing. If area is increasing, what happens? Flux also increases, right? So you will get E is equal to what? 2 into pi into r is how much? R naught plus t into b dr by dt is how much? Into 1. Into 1. E is equal to, what is the answer? 2 pi r naught plus t into b. Okay, now here it will produce a magnetic field of opposite direction. So again it will be in anti-clockwise direction only, because what is happening? It is increasing. Area is increasing here. Okay, area is increasing, flux also increases. Therefore this will produce a magnetic field which is in opposite direction of this one. Okay, cross. Okay, this is dot. It will be anti-clockwise direction. Anti-clockwise direction. Therefore the answer is 2 pi r naught plus t into b. Anti-clockwise direction is the right answer. Hope you understood. We'll see the next problem. What it is saying? A flexible wire bent in the form of a circle. Okay, they have given what? R versus T. They have given. Okay. Now, is placed in uniform magnetic field perpendicularly to the plane of the coil. The radius of the coil changes as shown in the diagram. Okay, radius is changing. This is A. Okay, this is A, this is B. See. Now here radius, you can see the radius is constant here. Radius is constant. What is formula for E? E is equal to, just now we wrote, E is equal to 2 pi r b dr by dt. Okay, I will take small r because here they have taken small r. 2 pi r into b dr by dt. You just see, you observe between 0 and 1. Between 0 and 1, r is what? Constant. Between 0 and 1. Okay, 0 to 1, r is equal to what? Constant. What is differentiation of a constant? dr by dt is equal to 0. Therefore E is also what? 0. E is also 0. Okay, that is from 0 to 1. From 0 to 1. Similarly E is equal to 0 from what? Again see, from 2 onwards. From 2 onwards, because it is constant. Radius is constant. Okay, from 2 onwards, it is 0. So EMF induced is 0, because dr by dt is 0. If you substitute, you are going to get E is equal to what? 0. Now if I observe this one, okay, if I observe between 1 and 2, between 1 and 2, okay, what is happening here? Okay, there is a what? It is linearly increasing. Okay, it is linearly increasing. Understood? Now R is proportional to what? R is proportional to T here. R is proportional to T. Okay, what is dr by dt here? Dr by dt, it is what? It is a positive slope. It is a positive slope. What will be the differentiation of a positive slope? Is equal to what? It will be a constant. It will be a constant. It will be a constant. Positive constant. It is what? It is a positive slope. It will be a positive constant. Understood? Positive constant. Since R is proportional to T, okay, E will be proportional to what? R. It will be also increasing linearly. Now we have to see the graph between 0 to 1, which is 0, between 0 to 1. This is also 0, this is also 0. Okay. Again, after 2, this is 0. Okay. Between 1 and 2, what is happening? Okay, it is EMF induced is what? Linearly increasing. Okay, 0 to 1. This is the right answer. Okay, and then it is 0 here. This is the right answer. Hope you have understood this one. This is very easy sum. Provided you should know this one. Between 0 to 1, EMF induced is 0, and from 2 onwards it is 0. Between 1 and 2, it is what? Linearly increasing, because here you are getting dr by dt is positive constant, because there is a positive slope here. Hope you have understood. Next problem we will see. The last problem. A conducting circular loop is placed in uniform. Okay, they are given B is equal to 0.04 Tesla. They have given with its plane perpendicular. Okay, the radius of the loop starts shrinking. Starts shrinking means dr. Okay, I'll take dr by dt. Dr by dt is equal to 2 mm per second. Okay, that is 2 into 10 to the minus 3. Okay, meters per second. Shrinking means what? Shrinking. Shrinking means what? Okay, area is getting reduced. Okay, shrinking. Anyway, dr by dt. The induced EMF in the loop, and the radius is how much? Radius is 2 centimeter. Converted into SI units. 2 into 10 to the minus 2 meter. Now, what is the formula for EMF induced? E is equal to 2 pi r b into dr by dt. Okay, that is equal to 2 into pi into radius is how much? They have given 2 into 10 to the minus 2 into b is how much? Tesla 0.04 into dr by dt is how much? They have given 2 into 10 to the power of minus 3. Right, that is equal to, answer they have given in the form of pi only. Okay, 2 into 2 is 4. 4 into 2 is 8. 8 fours are 32. 8 fours are 32. This is the only answer. So 3.2 pi. Okay, micro volts. Micro means 10 to the minus 6. You are going to get 10 to the power of minus 6, because the same can be written as what? 4 into 10 to the power of minus of 2. Understood? So this 2 into 2 is 4. 4 into 4 is 16 into 32. Okay, 32 into 10 to the power of minus 2 minus 2 minus 4 minus 4 minus 7, and again you can write this as what? 3.2 pi micro volts is the right answer. Hope you understood this. You might have enjoyed this video by solving these kind of problems based on what? Change of area in magnetic field. If you like this video, kindly share with your friends. Subscribe for my channel. Ask doubts in the comment box. You like this video if you really liked it. Thank you one and all. I wish you all the best for your KCET and NEET 2026.